Question on sound. State which wave property determines the pitch of a sound. So pitch is how high or low a sound is, and that's down to the speed of the vibration, because fast vibrations give high sounds and low vibrations give a low pitch sound, or slow vibrations give a low pitch sound. So that property is the frequency of a wave. Then we're shown the maximum frequency of sound heard by 4 animals and a human, and we're asked to explain which of the bars is most likely to show the results for a human. So first of all, we've got to correctly identify the bar, and then we've got to say how we know it is that bar. So the thing about humans is that our hearing range is capped at about 20,000 hertz. So if we look at all of those bars there, anything above 20,000 hertz is what we refer to as ultrasound. So if you look at C actually stops at 20,000. E has a maximum range lower than that, and all the other 3 are much higher. So we know that it must be C is the human. And the reason for that is because humans can hear up to a maximum of 20,000 hertz. We're told a sound wave has a frequency of 500 hertz. Show that the time period is 2 milliseconds. So a couple of things to spot here. Firstly, the show that. So that means you have to treat the time period as unknown and calculate it, but you are given a value so that you know when you get your answer that you have done it correctly. So we are not using the 2 milliseconds. We are simply ending up with an answer that should be close to that. And the other thing, I've already mentioned it a couple of times, is the fact that it is milliseconds. So remember that a millisecond is 1,000th of a second, so bear that in mind. So we go to our formula sheet and we find the relationship between frequency and time period, and that is that the frequency is 1 over the time period. So if we then rearrange that, we can see that time period is 1 over frequency. If we plug that in, we then have our time period is 1 divided by 500, and that gives us a value of 0.002 seconds. But we are asked to give it in milliseconds, and as we can see, because 1 millisecond is 1,000th of a second, then 0.002 seconds is equal to 2 milliseconds. We're shown a screen of an oscilloscope and told that the time base setting is 0.5 milliseconds per square. So the time base is the horizontal setting on our oscilloscope. So what that means is 1 horizontal square there is going to be equal to 0.5 milliseconds. We're asked to draw the trace for this sound wave that is detected. So we can see from part 1 that the time period is 2 milliseconds. Now the time period is the time for 1 complete wave. So what we're saying then is if 1 square is 0.05, and if we just put a line through the middle here first of all to start us off, we can see that in order to achieve a time period of 2 milliseconds, well, if each of these is 0.5, 1, 1.5, 2, so there is our 2 millisecond mark, we can see that we should have 1 complete wave in that time. So what we then have to do is to draw a complete wave. The amplitude here doesn't matter, but a 1 complete wave is 1 peak and 1 trough. So we have to have a peak so that half of the wave is completed within 1 millisecond, and then a trough for the second half of our wave. So there must be at least 1 complete wave. You can then go on and add an additional one if you want to, because that is okay as long as your time period remains the same. So that would then be 4 milliseconds, but you must have 1 complete wave in order to get the marks here. And 1 complete cycle must be 4 squares across.